Here's another example of using F equals ma that I would like to go over. So you weigh 675 newtons, which is the SI unit for weight, right? Because weight is really a force, and that corresponds to about 152 pounds. And you're in an elevator, and in fact you're standing on a scale in an elevator. And what you need to understand about a scale, like a typical bathroom scale, although maybe with a little bit more precision than a typical bathroom scale. What a scale shows you is it displays how much force it feels from you. Of course, that by Newton's third law, then that will be the force it's exerting on you, right? Equal and opposite. Now, if the elevator is going down at a speed of 6 meters per second, what does the scale say? So if you were just not in an elevator at all, right, and you stepped on this scale, it would tell you that you weigh 675 newtons, or 152 pounds. But now we're in an elevator that's going down at a speed of 6 meters per second. So an elevator is like a big box, and here's the scale, and you're standing on the scale. And this thing is going down 6 meters per second. And I want you to think about just the basics here. Do you think the scale will show it'll show you a bigger number or a smaller number compared to what you would be if you were just not in an elevator, just in your bathroom? So think about that. What do you think the answer is? And I've kind of made it slightly a trick question because I gave you two options, which is bigger or smaller, but the right answer is it's the same. It is exactly the same. And here's what's going on. So first of all, let's look at the case where you were just in your bathroom. So no elevator, you're standing on the scale, right? So if we look at U, let's say U, and we do a free body diagram, and so gravity is downward, and the normal force from the scale is going upward, because the scale is basically the surface that you're standing on. And those are the only two things that are interacting with you. Those are the only two things that are exerting a force on you: the earth and the scale. Now, of course, you are standing still, so you have no acceleration. You are in equilibrium. So this is kind of one-dimensional. I don't even really have to do a horizontal axis. I mean, I could, but up is positive, down is negative, and I do F equals ma. But again, equilibrium means no acceleration. So the normal force is the weight. So the scale is reading your weight, which is, I mean, none of us think of F equals ma when we do that, but this is the reason why the scale is going to display your weight, because we just proved that your weight has to be equal to the force that the scale is exerting on you, which is the force that you're exerting on the scale. So that's what it shows. So this is mg, but actually we don't even have m separately. We just knew the weight, so I don't even have to write that. This just is 675 newtons. 675, again, that is the weight, so that is Fg. I don't have to break it down into mass times 9.80. Okay, so now what is different in an elevator? Let's think about it. Free body diagram. Gravity is still down, and we're still standing on the scale, so that's our support, so that there's a normal force pushing on us. And again, we have then Fn minus Fg equals m times a. Now what's our acceleration? So the elevator is going down at a speed of 6 meters per second. Presumably that's constant, right? The way this is phrased, that is just staying at 6 meters per second. that's a velocity, that's a speed. And if it's staying constant, there's no acceleration. So again, this is 0. There is no acceleration. So everything plays out the same. And so the answer is the scale will show the same number, 675 newtons. It does not change. If you're in an elevator that's moving at a constant speed, the scale will tell you your actual weight just as if you were standing still. So that's a little surprising. And the thing is, scales work with force, and force doesn't care about velocity. Force cares about acceleration. Force is connected to acceleration, and acceleration is still 0. It's 0 in both of these cases. Now, what if the elevator is accelerating? What if it's accelerating? So now what if this either is getting faster going downward, or maybe it's accelerating upward, or maybe it's going downward but slowing down, so the acceleration is upward. If there is some acceleration for the elevator, now things will be different, and the scale will show a different number. Because what we'll have is Fn minus Fg equals ma, but now we can't say that a is 0, because it's not, because we're in an elevator that has an a. And so the scale, the normal force from the scale, will be the weight of the person plus ma, plus ma. Okay, so yeah, so if the acceleration is positive, then we're going to see more than our weight. Well, this will be adding a positive number to our usual weight of 675 newtons. Then the scale will show more than 675 newtons. So again, that's if the acceleration is going up. So either it's accelerating upward, or it's going downward but slowing down. Either of those, right? And that makes sense, because you get a little compressed. If you're going downward but you're slowing down, you've felt that in an elevator, right? You feel like you're being pushed a little bit. And so if you were standing on a scale, the scale would go up by some amount. And it would be as if you weighed more just during that acceleration. Now, a could also be negative. And then this will be actually sort of taking away from your weight. So the scale will show a number less than 675 newtons, or less than 152 pounds. That will be if the acceleration is downward. So if you're getting faster as you go downward, right? And again, that's like when you feel that butterfly feeling, and you almost feel like you're a little bit lighter. You feel like you're being lifted up off the floor of the elevator, slightly, right? Because you are a little bit lighter in the elevator. And if you were on a scale, that would show up. You would show up as lighter just during the acceleration part. Okay. Now the way elevators usually work is, of course, you get on the elevator and it's at rest, and let's say you're going up. You accelerate for probably about 1 or 2 seconds, right? And that's when you'll feel that positive acceleration, and you'll feel heavier. You'll feel a little pushed downward, right? But that only lasts a couple of seconds, and then the elevator goes up at a constant speed. And now everything's normal. And if you were on a scale, it would show your regular weight. But then as you get to the top, the elevator has to slow down and come to a stop, which means the acceleration would be downward, right? And then that's that lighter feeling that you feel, the butterfly in your stomach feeling, just for about a second or two, and then you're going to be less than 675 newtons, less than 152 pounds if you were standing on a scale. All right, so again, a big mistake that is easy to make for anybody is to confuse speed and acceleration. F equals ma is all about acceleration. And so if you're traveling at a constant speed, that has 0 to do with how F equals ma plays out. And therefore it has 0 to do with your weight. Okay.